the scalar speed is to distance as the vector velocity is to displacement. Let's look at a simple problem to show how these four important quantities connect. Xiaoqian walks 8 meters north and 6 meters east, and we need to determine her final distance and displacement and her average speed and velocity. For distance, it's easy. Just add them up. And her speed is just distance over time, giving us 2.8 meters per second. But for her displacement, we need to take into account her direction and figure out where she ends up relative to where she starts, which we'll choose to be the origin. She walks 8 meters north and then 6 meters east. Any self-respecting physics student would recognize this as a 3-4-5 triangle. But because displacement is a vector, we're going to need to give our answer with an angle. Any good physics student should also know SOLCAR-TOA. So here we have the adjacent, opposite, and hypotenuse. Now, we could really use any of these, but since the opposite and the adjacent were given to us in the original problem, and we used them to calculate the hypotenuse, let's use O and A. So we use tan theta and get an angle of 37 degrees. There are a few ways to express this direction, but I recommend stating the angle between that direction and one of the compass directions. The most important thing is that we can't just say northeast, because we need to be more specific and use the 37 degrees we calculated. So the answer is 37 degrees east of north. I encourage my students to think of east of north as actually being east from north, because if we start with north, then we need to move 37 degrees towards the east to get the direction we calculated. Finally, for her average velocity, we use velocity as displacement over time, so it comes out at 1 meter per second. Now this might seem a bit strange at first, because Xiaoqian never actually walked 1 meter in any 1 second. If her speed was constant, then she walks 2.8 meters every second, which is her speed we calculated before. This is where the connection to displacement comes in. Average velocity tells us how much further, on average, she moves away from the origin each second.